Hello again, everyone. Last time, we introduced the Cartesian coordinate system and plotting points. Today, we will apply that to graphing equations, or functions, that take in an x-coordinate and give back a y-coordinate. For example, an equation like this, where we have y equals some expression in terms of x. The most straightforward method to plot any graph from an equation is to create a table of x and y values. Going through this process will give a set of ordered pairs, x, y, for us to plot points on our grid, which will form the shape of the graph. We can choose whatever value of x we want to try to plug into the equation and write in our table, though we typically want to choose x's that are easy to plug in. To demonstrate, let's consider an x value of 0. Choosing an x value of 0 tells us that anywhere we see an x in our equation, we will replace it with that 0, like so. If we then do the math, we will get the value of y associated with that x. Those values of x and y then together make an ordered pair. We would then want to do the same process with several more values of x until we got enough ordered pairs to trace out the shape of our curve. To demonstrate, consider the equation given by y equals 2x minus 1. If we wanted to plot the graph for this equation, we would set up our table of x and y values. For our easy numbers to plug in, we typically look around 0, both the positive and negative sides, though the best choices for x can vary depending on the complexity of our equation. The number of points needed to get a good idea of the graph will also vary with complexity, but for now, let's just try the x values -2, -1, 0, 1, and 2. For each of these x values, we will plug them in wherever we see an x in our equation. It's usually a good idea to put the number in parentheses when you plug in, especially when dealing with negative numbers. So plugging in -2 for x, we get y equals 2 times -2 minus 1. Doing the math, we'll get -4 minus 1, which is -5. So the coordinate pair we get from plugging in x equals -2 is -2, -5. Plugging in our other choices for x, we'll get these 5 coordinate pairs. Now we'll need to plot each of them on our grid. To plot -2, -5, the x-coordinate of -2 tells us to go to the left by 2. Then the y-coordinate of -5 tells us to go down by 5. So our first point will end up here. Plotting all 5 points will give us something like this. Now that we have plotted all the ordered pairs we got from our table, we see the trend that this graph follows. We could also keep plugging in more and more x values between these points, which would start filling in the gap that we have here. If we did do so, it would start to look like a solid line. So rather than a bunch of spread out points, what the actual plot of this equation would look like is a solid straight line. And this is the procedure you want to follow for plotting equations. Get enough points to see the trend of your curve, and simply connect the dots in a way that follows that trend. At this point, I will make note that anytime we have a linear equation, that is something of the form y equals m times x plus b, the graph of the equation will always be a straight line. Also, one convenience of plotting a straight line is that we actually only need 2 points to construct the line. Let's make sure we can do the same process for a slightly more complex equation. Consider y equals x squared minus 2x. Because of the x squared term, this is no longer a linear equation, and therefore will not give us a straight line. As such, we might need a few more points to get a good idea of this graph. Let's set up our table of x and y values, and this time try to plug in a few more x values. Let's choose -3, -2, -1, 0, 1, 2, and 3. Once again, anywhere we see an x in our equation, we will replace it with these values of x's. Starting with -3, we'll get y equals -3 squared, being careful to use parentheses, especially with negative numbers, minus 2 times -3. Doing the calculation gives us 9 plus 6 equals 15. So our ordered pair from this x is going to be -3, 15. Repeating the process and plugging in each of these x coordinates will give us these 7 ordered pairs. Some of these y values go above where we have labeled on our y-axis, but let's plot the ones that we can. Starting with -1, 3, the first number, -1, tells us to move left by 1. Then the second number, 3, tells us to move up by 3, giving us a point here. Plotting the rest of the points and thinking about where our points that go above where we have labeled our y-axis are will give us something like this. Following the trend set by these points, we will get something that looks like an upwards shaped U. We call this U-shaped graph a parabola. And these shapes are formed from quadratic equations, ones that have the highest power of x being x squared. You will find more in-depth looks at the types of graphs and equations in the future, but for now, setting up our table of x and y values is the most universal method of plotting equations. Until next time.